Last time, we talked about functions. We said that functions are little blocks of functionality that we can repeat over and over again. So instead of rewriting those 10 lines of code that makes the car move forward, we can write it once in a function. Now, we can make that car go with one line of code. Last time we took the distance, which was a variable that we defined outside of the function. It would be much more interesting if we could make the car go a specific distance. It would be much more interesting if we didn't have to define that distance outside of the function. It'd be much more interesting if the function wasn't directly tied to some variable that we made outside of it. Think about a baker. Now, a baker can give you as much cake as you want, but in order for him to give you that certain amount of cake, you have to give him a certain amount of money. The more money you give him, the more cake he can give you back. So let's say you had a party and you knew that you needed a lot of cake for this party. So you create a function that creates cake based on how much money you give the baker. You give the baker money, he gives you the cake. These are two new concepts that we haven't covered yet, although you've probably covered them in life. You have the idea of a function taking in a value. This is called a parameter. We can make a function that takes any number of parameters. In our case, we want a function called makeACake, and that takes in a certain amount of money. When you think about money, how would you represent it? Would you represent it with an integer or a double? Well, money has cents as well as dollars, so we need to represent money with the floating point numbers, numbers that have decimals. That's perfect for doubles. To start off, we'll make our basic function. You already are skilled in this area, so let's write it. You would write func make a cake and save it. Inside of those parentheses, which we didn't talk about last time, we can tell the function that it's going to need certain things in order to work. In our case, we need a function to accept money and do something with that money that we give it. So let's write in those parentheses some constant called cash. We need to tell Swift what type of thing that cash is going to be. In our case, it's going to be a floating point number, aka a double. So we need to write $double when we write our constant. Here we're telling the code that when someone calls this function to pass in a double, that double will represent the cash. That cash will be made available to us. So we can rewrite this function by writing cash $double. Now we can do anything we want with this cash that we are given. I wonder what our cash to cake ratio is. Well, let's say for that every dollar we are given, we give them back twice as much cake in pounds. So let's print this out that we will double the cake for cash. Kind of sounds like one of those cheap loan schemes. So inside the function, we can write print line, and we can say making cash times 2 pounds of cake. Nothing is going to happen yet because we didn't actually call the function. Let's call the function at the very end to put everything into motion, to make this thing happen. Without calling it, we just have some block of functionality that has been saved for use later. The time has come to put this function into use. In our case, let's say we want 10 pounds of cake, so we'll pass in $5 in cash. At the bottom, we can write make a cake, and the cash will write 5. Now it says making 10.0 pounds of cake. Do you know why it says 10.0 pounds of cake and not just 10? That's because we made the cash a double up here, and a double has a floating point number. Integers do not. So you can pass in more than one parameter to your function as long as you write your function to take the right amount of parameters. Let's make one more parameter that accepts the cake to dollar ratio. Let's rewrite our function to say ratio double. And now we have to change our function. Instead of 2, now we can write ratio. Now we're no longer bound to that number. Now we have much more control over our baker. We can tell him what the cake to dollar ratio is. Notice how flexible our function is now, but notice that we also have a big error on line 9. When we call the function, we're getting an error because we added one more parameter to the function, but we're only calling one of them on line 9. We need to add one more parameter to our function call. So we can rewrite this on line 9 to say 5 and 3. Now we get back that it's making 15 pounds of cake. This is great because it provides a lot more flexibility than we had previously, but now we're kind of stuck because our function just prints out information and it doesn't actually do anything with it. It would be much nicer if it just, instead of printing out how much cake it was making, we could get the number back, and then we could print the number ourselves. Can you imagine if we didn't have access to this function? If we didn't have the actual code in front of us, it would always just print out this message, and that would be completely useless to us. What we really need is for this function to just return the amount of cake that it's making. Essentially, this baker didn't just give us the cake, he just told us how much he was making. Functions can take in parameters, like we just saw, so that they're more flexible and that they can also return stuff too. You can mark a function to return stuff. When your function returns things, it isn't just functioning and getting things done, like making the car go forward, but it's also a tool for providing you more information about what it has done. In the last tutorial, we talked about getting the 200th prime number. If we wrote that function currently, we would just be able to print out what the 200th prime number would be. What if afterwards we wanted to then add 5 to it after it was calculated? In that case, we would need the function to return some sort of value. We need to tell Swift that we want our function to return something. We can do this with a funky little syntax that looks like an arrow. In our case, we're going to return a double. So we need to tell this function that we want to return a double. So we can rewrite this function a little bit by writing a little arrow and then writing a double. You changed your first line to have that little arrow syntax pointing to a double. This tells our function that we're going to make a cake and return to us the amount of cake that it made in the form of a double, a floating point number. Notice how we named our parameters. We have one named cache and we have one named ratio. We gave them each a name describing what they're for. We want the user to pass in a certain amount of cache, so we named the first one cache. But we didn't name the return. We just wrote double. Why didn't we do that? Why didn't we name it something? Well, when we write the function, we name the function something that tells us that it's going to return the poundage of cake. There's also ways to name the return, but we're not going to talk about that right now. Now we have to update our function so that it actually returns the amount of pounds of cake instead of just printing a message. So we have to write return there. We use the word return to say return this. So our function is going to return the cache times the ratio. Now we can use this function and its return and save it into a variable and then print the sentence, just like we did before, except we have more flexibility now. So we can make a variable called cake made, and that's going to be equal to the return value of make a cake. Now we can write a print line and we can say we made cake make pounds of cake. That should be cake made pounds of cake. We made 15 pounds of cake. This just scratches the surface and barely introduces you to function return values and introducing parameters. We're definitely going to cover this more, but it's good to just understand it initially. Thanks so much for watching. I'll see you next time.